This next problem, we're going to solve a system of linear equations using substitution or elimination. We have a system of 3 equations and 3 unknowns. We're going to use the method of elimination to solve this. Our system is 3x plus 2y minus 8z equals negative 3, negative x minus 2/3 y plus z equals 1, 6x minus 3y plus 15z equals 8. First thing we'd like to do is, here in equation 2, we'd like to get rid of the fractions so we can work with integers. To do that, we're going to multiply this equation by 3. That'll give us an equivalent system. We're not changing the first or third equations, so we rewrite those. 3x plus 2y minus 8z equals negative 3. We're going to multiply this equation by 3. We'll have negative 3x minus 2y plus 3z equals 3. And again, we're just going to rewrite our third equation. We haven't changed that. 6x minus 3y plus 15z equals 8. We're using the method of elimination. We're going to eliminate the variable x from the second equation. We're going to use our first equation to do that. If we notice that the coefficient on x in the first equation and the coefficient on x in the second equation are the same except for the sign. So we can simply add these two equations together to get rid of that variable x. So we'll have 3x plus 2y minus 8z equals negative 3. Negative 3x minus 2y plus 3z equals 3. We add those together. 3x plus a negative 3x is 0. 2y plus a negative 2y is 0. Negative 8z plus 3z is negative 5z. And negative 3 plus 3 equals 0. This will become our new equation 2. Next thing we'd like to do is eliminate the variable x from the third equation. To do that, we're going to multiply our first equation by negative 2. That'll give us coefficients on x that have opposite signs but the same absolute value. If we multiply by negative 2, we'll get negative 6x minus 4y plus 16z equals 6. We're going to rewrite our third equation, 6x minus 3y plus 15z equals 8. Since our coefficients are the same except for the sign, we're going to add these together. Negative 6x plus 6x is 0. Negative 4y plus negative 3y is negative 7y. 16z plus 15z is plus 31z. And then 6 plus 8 is 14. This would become our new equation 3. We're going to rewrite our system now so we keep track of where we are. We haven't changed our first equation, so we're going to use 3x plus 2y minus 8z equals negative 3. We're going to write down our second equation here, negative 5z equals 0. And we have our third equation, negative 7y plus 31z equals 14. We're now going to use our new system of equations to solve this problem. If we look at our system, we see that this second equation only involves one variable. So we can easily solve that for z. Negative 5z equals 0. If we divide both sides by negative 5, it gives us z is equal to 0. So now we know what the value of z is. When we look here at our third equation, we notice that this equation depends on y and z. We know the value of z already, so we can back substitute that into our third equation. Negative 7y plus 31z equals 14. We're going to plug in our value for z, 0. So we end up with negative 7y is equal to 14. Divide both sides by negative 7, so y is equal to negative 2. So now we know the value for z, and we know the value for y. We can take each of those values, plug them into our first equation, and we can use that to solve for x. 3x plus 2y minus 8z equals negative 3. We're going to plug in our values for z and y. 3x plus 2 times negative 2 minus 8 times 0 equals negative 3. 3x minus 4 equals negative 3. Add 4 to both sides. 3x equals 1. And divide by 3 to get x is equal to 1/3. So we now know the values for x, y, and z. So our ordered triple solution is 1/3, -2, 0. Again, you should go back and check the solution into the original system of equations to make sure that it satisfies all three of the equations.